Well, I have 11:15 on my clock, so and since I always overrun anyway, I thought I'd get started. Today I want to talk, of course, about Marie Curie, and this written back in 1680 about there being no difference. In fact, from all the little bit of research I know how to do in medical fields, seems to be true that.
Camera just technical switch. I'll just
What?
fix it. Switch it on. Also, the people can see online.
Okay. That except for size, because women are not in general as large as men, there seems to be no physiological difference between brains. Now, physics and its related science, astronomy, these ask questions about the nature of the universe that we've been trying to talk about. And of course, from the tiniest scale, that of the quarks, which make up these point-like objects, which make up the proton and the neutron, to the largest scale of the cosmos, it is a different world than the one of the meter or kilometer in which we live. And it has a language, of course, which I have mentioned several times, that it speaks the language of mathematics, a language which is incapable of misunderstanding. It's either right or wrong. This language and the structure it supports is, in my mind, one of incredible beauty. And it can be, parts of it can be understood in the same way that we can understand any other beautiful subject. Somehow, I have never really understood why it is that some people say that understanding a beautiful object somehow decreases its importance, so that, you know, the fact that I understand how raindrops cooperate to create a rainbow, or how atoms in oxygen and nitrogen atoms work to give us a blue sky from sunlight, that just makes those phenomena even more beautiful and important. So it only adds to my pleasure. I don't understand. But what I really don't understand, and in fact it's shameful, is why these beautiful fields of physics and astronomy, science in general, but physics and astronomy in particular, seem to attract so many more men than they do women. I honestly do not understand that, but of course the denigration of women extends far back into human history. It's just sad, I think. Women have clearly struggled to succeed in the sciences, and aside from medicine and maybe some of the biological sciences, this is still true. And it's particularly true in physics, which is awful. But I want to show how two women whose surname Curie have managed to overcome a great deal of that. And I'm especially pleased to talk about Marie Curie because Marie and her daughter Irene are the only mother-daughter team ever in history to win Nobel Prizes. There have been fathers and sons who have won Nobel Prizes, of course, several of them in physics, J.J. and G.P. Thomson. George Thomson won a Nobel Prize in Physics, and we are incredibly honored to have their daughter and granddaughter here today, which is for me a super pleasure and honor. But also William and Lawrence Bragg, Niels and Owe Bohr, Kai and Mana Zsigpan have also won. Now, Maria Sklodowska was born on the 7th of November in 1867. She died 76 years later on July the 4th, 1934, of leukemia, almost certainly induced by exposure to the radiation with which she worked so long in her life. She was the fifth child in her family, and a very bright young woman, reading poetry when she was still at school. She was reading poetry in Polish. She was born in Warsaw, in Polish, in French, and in German, all in their original language, still as a school child. But life in those days was harder, and there were many sadnesses. Her older sister Zosia died when Maria was just 9 of typhoid, and her mother, whose name was Bronisława, died just 2 years later of tuberculosis. Her father was a physics teacher at a local high school. And like so many school teachers, he was poorly paid, so they didn't have a lot of money. And lived and studied a great deal of sciences. I have a picture here of her parents, Władysław and Bronisława. And she finished school at 16, winning a gold medal, graduating first in her class, and the highest possible marks in every single subject. She was uncertain of what to study because she was good at everything at university, but because of the influence of her father, she chose various sciences. However, she had a relative who was living in Paris at the time, and she and her older sister, whose name was just like the mother, was Bronisława, they just wanted to go to Paris and study at the Sorbonne. Her sister was older, so she went first, and Maria, who had very little money, needed a job and took a job as a governess for some young children of a very wealthy family in Warsaw. That family had a son who was her age, and not surprisingly, young people, they dated, they went out together and fell in love. However, she was not of the same social class as he was. His parents disapproved of her. He was not strong enough to overcome that. And so her experience of first love was very sad and disappointing, something maybe many of us have undergone. I have some pictures of Maria on the left here. She's 15 years old. This is also a fairly young woman, and I like this picture a lot. She's a very beautiful young woman. She was decided to go to start studying at the university in Warsaw, and she had access to the Warsaw Museum of Industry and Agriculture, where she got a position of working, and she started doing chemical analysis, what's called qualitative and quantitative analysis in chemistry, a means of measuring the amounts of material in a chemical substance that have very small traces. And this served her in enormously good stead, as we will see, when she came to the discovery of radium. When her older sister, who had gone first to Paris, married a Frenchman in Paris, and they had a reasonable amount of decent living, and so they invited her when she was 24 years old to move to Paris. She took the train, of course, from Warsaw to Paris, and I'm told she had very little money. She took the train in fourth class compartment. I didn't even know trains had a fourth class, but apparently they did in those days. And she got there and enrolled in the Sorbonne. She was fortunate because this was 1891, but in the next year, she won a scholarship and had a decent amount of money. She was 24 at the time. 2 years later, at age 26, she got her first degree, highest honors at the Sorbonne. She first in her class. 2 years later, she got a second degree, this time only second in her class, but she was obviously a very fine student. And she was also working at the Society for the Encouragement of National Industry in France. She was working on the properties of different sorts of steel. She was doing a lot of chemical work, which was stand her in good stead in the future. And she was looking at the ways in which the composition of steel and the tempering of steel contributed to its strength. Now, the laboratory that she had was too small, and so she needed more room. And so she appealed to some friends of hers, a woman that she had known from Warsaw. And this woman was married to a Frenchman, and he had friends who he thought could help find her a bigger room. And so he invited a good friend of his, whose name was Pierre Curie, to come, and they should meet, and he could perhaps provide her with a lab space somewhere, because he was already very well-known scientist. He had invented, or discovered, if you will, the subject called piezoelectricity. This is a subject where if you have a certain material, usually containing titanium, and you put a stress of any kind on it, it develops an electrical charge and therefore a voltage. And this may seem not very useful, but it is how microphones basically started to work, because a sound wave puts air pressure on a piece of this material, and that pressure then creates a charge, which is then a voltage, and that can be amplified and magnified and therefore rebroadcast. And so early microphones were made in exactly this way, and it was Pierre Curie who discovered this principle. So Marie's friends arranged a meeting and invited both Pierre and Marie. They obviously took a great liking to each other, fell in love, and got married a year later. She was given permission, if you will, to work in her husband's laboratory. And because of marriage, she was given French citizenship. the money they got for their wedding went to buy bicycles, which were a very new form of transport in 1895, and off they went on a honeymoon by bicycle, which just sounds like fun. She had finished her work on the properties of steel, and then on the 12th of September in 1897, she gave birth to her first child. His name was Irene in French, or Irene in English. As I've said, and we'll say again, Marie and Irene are the only mother-daughter team ever to win Nobel Prizes. Marie, as we shall see, won 2 Nobel Prizes, and Irene came really close to winning 2 Nobel Prizes, but only won 1. It's not so bad. But after her recovery from giving birth, she went back to work in the laboratory and decided to write a doctoral thesis, and that thesis changed the world. The very end of the 19th and beginning of the 20th century mark the dawn of modern physics, and I claim that that is the greatest revolution in intellectual history amongst that human beings have ever done. It's the growth of relativity and quantum mechanics, and which has changed the entire world. Up until the 17th century, most science was just alchemy, and we have an incorrect feeling for alchemy. I mean, it's turning lead into gold, and that's only charlatans did that. There was a lot of very serious investigation done, all incorrect, but all done under the name of alchemy. But it was then starting in 1680 when Robert Boyle wrote a book called The Skeptical Chemist, that we began to substitute chemistry for alchemy. And it was there that the idea of a chemical element first arose, that all matter is composed of some basic elements, of which we now know there are 92 in the world. But it really wasn't until the 19th century and the English chemist John Dalton that we really began to understand something about chemistry and elements. In 1869, a Russian named Dmitry Mendeleev organized what were then the 63 known chemical elements in a way we now call the periodic table. This is just a picture of Mendeleev's, but it now looks like this, and this is something that every chemical student has to look for. I put arrows here because there are 92 elements that naturally occur on Earth, and the ones above this, 93, 102, 103, up to 118. These are all non-naturally occurring, and they are all radioactive. There are 2 elements here that are natural, that we find on Earth, that are radioactive. This is uranium here. Here is plutonium. There's an element named curium, after Marie Curie. And this one I like a lot. Meitnerium is named after Lisa Meitner, the only other woman who has a chemical named after her. I had a bit of a crush on Lisa Meitner, even though she was 60 years older than I am, but incredibly lovely woman. There's radium, 88, etc. Okay, anyway. it was a technological invention that allowed us to make a great deal of progress. Invented in 1850, a German glassblower at the University of Bonn named Heinrich Geissler learned how to, people knew how to blow glass. He learned how to stick a piece of metal into glass and form it so that the inside of this metal bulb was was independent of the outside air. And so it could either be a vacuum or you could put a low pressure gas in it, which is what people did. And this tube was used for decades, called the Geissler tube. Today we call it an X-ray tube. And it is a means of putting a voltage between a plate on either end of this, and one end emits electrons and they come through and things happen, which we'll talk about. Now, what we found originally is that the negative electrode, and the negative electrode is called a cathode, which is a word that Michael Faraday invented from Tuesday's discussion. And that was giving out some kind of particles. It was found in 1876 that these particles could be bent by a magnet. And that meant that they were charged, electrically charged, because charged particles, when they pass through a magnet, are bent from their original direction. It was also found that they could be influenced by electric fields, by the strength of by electric field. And so a tube was made by Joseph John Thomson with parallel plates that had both a magnetic field and an electric field, and you could then deflect and measure these particles that were coming off, and he discovered what we now call the electron, which was a particle extremely light compared to the lightest of elements, hydrogen, and the fact that there was some object that was therefore lighter than the lightest known atom meant that the atom, which comes from the Greek word for indivisible, had structure. There were parts of it. And in addition, if since atoms are known to be electrically neutral, if they had parts that were negatively charged, they also had to have parts that were positively charged. The atom had to have structure. Now, we have here a picture of Thomson's made a model of the atom, which had the electrons stuck into a ball of positive charge, and it's generally called the plum pudding model because these tiny little things were stuck in like raisins in a plum pudding. But it was found, as we now know, that atoms don't look at all like that, that they have a nucleus with the positive charges in it and the electrons outside. And the nucleus, which has all the mass of the atom, is incredibly tiny. It is between 10,000 and 100,000 times smaller than the atom itself. It's as I will probably mention at some point, you could get over 1 million atoms across the width of a single human hair. Okay? So it's a very small object. Yet the nucleus is 1,000 or 10,000 to 100,000 times even smaller than that. Now, a year before Thomson's discovery back in 1895 in Germany, Wilhelm Röntgen was investigating cathode rays. he didn't use a battery to provide a voltage between the negative and positive plates in his Geissler tube. He used a very high voltage system, which didn't, in a battery provides a voltage all the time, constant. But he invented a coil system which provided occasionally a very high pulse of voltage. And so something came out from in this tube that he had that didn't look like the electrons that Thomson had found in his tube. And he found that, well, he found things happening. For example, when he fired this thing at high voltage, he had a piece of aluminium sitting over here that had some fluorescent paint on it, and it glowed. And he thought, well, some sort of phosphorescence is the object you put in the sunshine and it glows. So he wrapped the tube in black paper to see whether something else would happen, and it still glowed. And so that was a very great puzzle. He didn't understand that. Whatever it was seemed to pass through material. So he would take and put some object in front of his tube, and whatever was making the paint glow passed through it. He even put in a book of 1,000 pages, and something still went through that. He had no idea what was going on. So since in algebra we use the symbol X for something unknown, he called these X-rays. And we still call them X-rays. And that's what he had discovered. Now, he thought that this was some sort of phosphorescence, things glowing in the dark. He eventually was holding up a piece of lead in front of the tube at one point, and the lead stopped this stuff. But what he could see were the bones in his hand. And then several months later, he took a picture of his wife's hand, the first X-ray picture ever taken. It frightened the dickens out of her. She said she was really terrified and said, I have seen my death, she said. But of course, she lived 50 years longer after this, and she died at 80 years old after being married to Röntgen for 40 some years. But of course, what's happening is the dense material of bone is stopping the X-rays and the flesh is not, and so we're seeing the shadow of the X-rays in her hand. Now, a Frenchman, Henri Becquerel, was very interested in this phenomenon, and so he was trying to understand what made things glow like this. And so he had a rock, a material that had this phosphorescent property. And so phosphorescence is a thing where you put some object out in the sunlight and it absorbs sunlight for a while and then it glows in the dark. And so he did this, and he was interested in whether these kinds of rays were really phosphorescent or not. So he wrapped the object in black paper and put it out in the sun so the sunlight couldn't get it. And then he put it on a piece of film, and it still exposed the film. So something was coming out that was not created by the sun. And so he was trying to do experiments with this, but this is February 18th. The sun does not shine very often. And so he couldn't expose things to the sun, so he put them in a drawer and left it there for a couple of weeks until the sun shone again, but it didn't. And so he thought, well, maybe it has a memory and the phosphorescence will last a little longer. So he took the rock, which had been in that drawer now for 2 weeks, and put it on a piece of film. And the film was coal black, which startled him no end. Why was this true and what was happening? Now, we understand because what was the rock had in it chemicals called potassium uranyl sulfate. That is, they had potassium atoms and uranium atoms and sulfur atoms in there. And so being a good scientist, having no idea what was going on, what he did was take some potassium and put it on a piece of film, take some uranium and put it on a piece of film, and some sulfur to see what happens. And of course, the uranium blackened the film, and what he was seeing were basically gamma rays coming off the uranium, the things we call now. This was the discovery of what Marie Curie invented the name radioactivity to describe. There's an interesting aside to this story that has something important, I think, about the history of physics or science in general, because this exact same phenomenon had been discovered 40 years earlier in Paris. Precisely this kind of glowing in the dark sort of thing, and had been reported to the Academy of Sciences and ignored. And because scientific experiments, and if you read historians of science who talk about this a lot, they have to be at the right time for people's understanding of what's going on. It was really only the interest and ingenuity of Marie Curie that made a difference and made this understood at the time. Now, Marie Curie, Marie Skłodowska-Curie, chose this discovery to pursue for her doctoral thesis. She decided to measure the amount of electrical charge that was coming out. And so I won't bother you with how she actually did that. But she was working on her doctoral thesis, and at the same time, she had an infant child, which made, of course, her work a lot more difficult. Still, nonetheless, she published 3 papers with a child of under a year old. She was the sole author on the first. Because the work she was doing aroused such interest, her husband, Pierre, abandoned his work and joined her. And the second paper they published together, and the third had a laboratory chief as well. And the first paper has some major discoveries in it. She not only confirmed what Becquerel had done, but she discovered not only that also there was another element, because what she did was test virtually every known element at the time. And she was incredibly systematic. And the element thorium, which is number 90 in that chart I showed you, that also created this effect. And so this thing, which was called after uranium, could not be only due to uranium. There was another element at least. It was in the second paper that she wrote with Pierre that she first used the term radioactive substance. a term again that she invented. And there's a lot, one of us, it says, MC, for Marie Curie, has shown that radioactivity is an atomic property. As I will repeat several times, this was extremely early in the history of atoms. And there were lots of people who didn't even believe that atoms existed at the time. But it's the first known reference of radioactivity linked to individual atoms. She went on to decide to investigate other minerals that had uranium in it, one of which is called pitchblende, an element found in mines in Czechoslovakia, where they used the pitchblende, which has uranium in it, to make yellow glass, which it does. And the pitchblende emitted radioactivity 6 times more than what it should have for the uranium content. Something strange was going on. So we knew how much uranium was. Oh, yes, ma'am.
They actually have the glass made with uranium that glows in the dark, glows bright green.
Yes, actually. I mean, the uranium in the glass was radioactive, and
the glass itself glowed bright green.
I don't know that it actually glowed in the dark, but it was probably not safe to drink water from. Yeah, but it was an attractive glass, I think. That's an interesting point, which I hadn't considered. Thank you. She knew how much uranium was in the pitchblende, and the radiation was much stronger. And so what she deduced from this, which was truly remarkable, is that the pitchblende itself must contain some as yet unknown element, which is radioactive as well as uranium, because something was making it 6 times more active. I'm deeply impressed by the conclusion that she made. She and Pierre then did a lot of interesting things, and they isolated a substance from the uranium that was 400 times more intensely radioactive than uranium was. And this result, which they published on July in 1898 in the French Academy of Sciences, and they suggested the name polonium for this in honor of her native country. And polonium is a well-known element. It's the first time in publication that the term radioactivity was used by Marie Curie. It's number 84 in the periodic table, and it is one of the most dangerous elements we know in terms of its radiation. It has very little commercial use, but some of us, at least those of us who live in London, will remember that it was used to assassinate Alexander Litvinenko back in 2006. It was put into a drink that he imbibed and eventually died from. We proposed to do something, I don't know what. Now, at the end of 1898, they discovered still another radioactive element in pitchblende, and they named this radium, and it is the largest spontaneous emission of any known element in nature. It's about 100,000 times more radioactive than uranium, and it's element 88. And in her notes, Marie noted that Irene then had 15 teeth. So she was also a mother all this time. The physics question, now, what was happening is particles were coming out of this material and they were moving. And moving things have energy. Where does the energy come from to shoot these things out? And this is well before Einstein. We're talking now 1898. Einstein was, as you'll see tomorrow, 1905. So it's 7 years before Einstein, because the answer is E equals mc squared, but they didn't know that, of course. And in a paper she published alone the next year, she discussed what was the problem and said maybe the interior structure of the atom is causing this energy. Now, this is well before the nucleus of the atom, almost 20 years before the nucleus of the atom had been discovered. So it was truly remarkable. She even wrote, the radiation may be an emission of matter accompanied by a loss of weight of the radioactive substances. Yet again, E equals mc squared. Six years now before Einstein. Truly remarkable stuff. The idea that the structure of the atom was somehow causing this was well beyond the what was known at the time, of course. And the business of doing this research and of taking care of an infant meant that it was 1903 before she actually got around to writing her doctoral dissertation. Took her 4 or 5 more years. And shortly thereafter, the discovery of radioactivity was so significant that the Academy of Sciences in Sweden awarded the Pierre and Marie Curie half of the Nobel Prize in Physics for the year 1903 for the discovery of radioactivity. For reasons I'll mention in a few minutes, they were unable to attend in 1903, but in 1905 they did. And shamefully, but not surprisingly, the acceptance speech was given by Pierre with Marie sitting in the audience. They wanted to find out this material, radium, they wanted to find out what it was. And so what they had found was it existed because they could see the radiation coming from it, but they didn't know what the element itself was, and they wanted to try to isolate that. And there is a huge difference between finding the radiation from a few million atoms in a material and actually getting a gram of that stuff around, or a microgram of that stuff. A gram of material contains something like 1 trillion times 1 trillion atoms. So, a number of 1 trillion. For example, if I rub my feet on the carpet and get an electric shock, ouch, maybe that's a few billion or maybe even 1 trillion electrons. It's nothing. It's a teeny tiny fraction. These numbers are astonishingly large. One of the things that happened is Henri Becquerel was a friend of the Curies, and he had a little bit of this pitch blende, and he put it in a glass tube, wrapped it in a piece of paper, put it in his pocket. About a week later, he noticed that his thigh was bright red, burn. Okay. And so Pierre Curie was interested, and he tried the same experiment, also was burned. The first example we have of the fact, which people did not know, that there could be physiological effects from radiation. And of course, radium became an incredibly important thing, first for the treatment of disease, cancer in particular. What was not understood is that, of course, it could also cause cancer, but that eventually did, of course, become obvious. They also discovered, the Curies, that putting non-radioactive elements in the vicinity of radium could actually cause some of the atoms to become temporarily radioactive. So they discovered induced radioactivity. So the whole idea now was not only did atoms exist, but you could actually change the character of one atom of an element to another atom of an element. Remarkable differences. There is again, there's radium, there's lead, which there's this gas which Ernest Rutherford discovered that comes about from the decay of radium called radon. And this is actually a very dangerous gas. It is radioactive, and it occurs naturally in our air. And caused by particles coming in from outer space. And it is also often in the basements of homes and has been known to cause lung cancer in people. It's something that is a non-trivial effect of these things. They had written things like back in 1900, and this is again years before, radium would constantly emit small particles with a negative electric charge, namely the electron. The energy would gradually disperse, and if we accept this, it is inevitable that we can no longer consider the atom to be unchanging. So they had discovered radioactive decay. It's a really profound statement. A string of radioactive elements, radium decays radioactively into francium, and then radon and to actinium, and eventually winds up as lead. So there is a chain of radioactive decay. Atoms are no longer immutable. And of course, as I think I said, Marie Curie submitted her doctoral thesis on this in 1903, the same year she won the Nobel Prize. Makes you wonder if there's anywhere, if you win the Nobel Prize for your PhD dissertation, there may be no way to go but down from there, although she did not. In 1920, Louis de Broglie won the Nobel Prize also for his doctoral dissertation, and he never did any other significant work. But Marie Curie was not like that at all. Yeah, this didn't, not all of this comes out. I tried to shrink these things, but it didn't seem to work. If we to accept this theory of radioactivity, we will have to concede that radioactive matter is not in a normal chemical state. In this case, the atom is not unchanging and indivisible since its particles are radiated out. Radioactive matter is subject to chemical transformation. The atom itself is subject to change. These are remarkable things. Radioactivity is a nuclear phenomenon. It's not an atomic phenomenon, but the nucleus had not yet been discovered. Yeah, the idea that atoms even existed, as I've tried to emphasize, was controversial. And here is a statement, which again, I'm sorry, doesn't come completely out. In 1877, a very famous French chemist said, "When one sees excellent researchers convinced that particles they have never seen join together, repel each other, search for each other. The atom searches for a locksmith to rivet it to a neighboring atom. All of that is absurd and should be avoided." So what the Marie Curie was doing was truly revolutionary. The Royal Society of Great Britain considered that the radium work to be the greatest chemical achievement of 1903 and awarded the Curies, who had already won the Nobel Prize, their highest honor, which is the Humphrey Davy Medal. Now, in 1903, when they won the Nobel Prize, she had been pregnant, had fallen, had given birth prematurely. The baby had died, and she needed to recover. And that's why they could not go to Stockholm to receive the prize. But they did, of course, go, as I said, in 1905, and she had to sit in the audience. And when in fact, the prejudice, when the prize was first mentioned and notice sent to Pierre, it was suggested that only he should receive the prize and not Marie. And he immediately wrote back to the Swedes saying that the discovery was in fact made by her and not by him, and she most certainly deserved to be given it. In his acceptance speech, though, he did say he warned humanity of evildoers who, by dragging nations into warfare, might use the achievements of science about the structure of matter as a weapon of destruction. This is 40 years before the construction of the atomic bomb, which is not atomic, it's nuclear, but it's called the atomic bomb. Their work and the Nobel Prize gave them a lot greater attention, and Pierre was made a professor at the Sorbonne, and he was given an office, and Marie was given the position of a tutor. Rather pitiful reward, I would think. But she was given a reward. They were given a reward of 140,000 francs to further the research. And in December of 1904, she had another child, a second daughter named Eve. And Eve was the only Curie not to do any science, but she wrote a beautiful biography of her mother, which I have read, and I highly recommend. It's still available. In 1904, the French built a factory for the production of radium for medical purposes, and she stayed in touch with the radium industry throughout her life. All of the early work on radioactivity had been conducted originally in Pierre's school before he had a position at the Sorbonne. And Marie had been teaching at a girls' school to get some kind of income, despite, of course, both working and having a child at home. But now Pierre was elected a member of the Academy of Sciences in a position at the Sorbonne. And Marie was named an assistant and for the first time had a salary. So she finally had was paid for her work. Up until that time, everything she had done had been voluntary. But both Pierre and Marie were quiet and shy and very introverted people, and they never made a penny from any of their research. Science was only for the pursuit of knowledge. Even though an industry of the use of radium grew up around them, the Curies had no part in it at all and never made any money from that. By the year 1906, Pierre's health was deteriorating, and perhaps he was an absent-minded professor, I don't know, but he was crossing the street in Paris in 1906 on a rainy day and not looking where he was going, and was run down by a horse-drawn taxi, his skull crushed by the wheel, and died instantly. This is written by Eve Curie in the biography of her mother. When the words "Pierre is dead" reached her constant, a cape of solitude and secrecy fell upon her shoulders forever. Not only a widow, a pitiful and incurably lonely woman. It's very sad indeed. Eve was a war correspondent during World War II, and she served in de Gaulle's government in exile in London during the war. In 1954, she married a diplomat who was the director of UNICEF, and he received the Nobel Prize, the Nobel Peace Prize for UNICEF. She lived a very long time. She died in 2007 at age 103. There is Marie in 1906, shortly after the death of Pierre, with Irene here and Eve there. So, of course, now Pierre was dead. She was caring for two small children and did not lessen her scientific work at all. But of course, they had some money, or she had some money, so perhaps she could help with childcare. The Sorbonne asked her to fill the vacancy left by Pierre's death, and she was promoted to lecturer. And the French journal wrote the following, which again doesn't show up, but it says, "A victory for feminism. If a woman is allowed to teach advanced studies to both sexes, where after all will be the pretended superiority of man. I tell you, the time is near when women will become human beings." 2 years later, after this, she was made a professor at the Sorbonne, the very first woman ever to be awarded such a rank in France. But we'll see there were still a lot of hurdles and things in her way. By the end of 1909, she had honorary doctorates from the universities of Edinburgh, Geneva, and Manchester. She had been elected to the Academy of Sciences in St. Petersburg, Russia, in Bologna, in Prague, in Warsaw, but not Paris. Pierre had been a member, but of course he was dead, and his position, it's a fixed number, had been taken by someone else, and that person died in 1910, and that left the position open, and she was encouraged to apply. She had received awards from the Academy, but was not yet a member. She was first voted the highest applicant amongst 6 people nominated, and then the French press started after her. The French press, of course, had a scurrilous reputation from the Dreyfus affair some 15 years earlier, but they started writing unfavorable articles about her, claiming that Pierre had done all the work and she was just helped him out a little bit. But what really hurt was what was called the Curie-Langevin scandal. She had been a widow now for some 6 years, 5 or 6 years. Pierre-Paul Langevin was a very famous French scientist who had been a close friend of Pierre, had gone to university with him, and stayed in contact with Marie after his death. By 1911, Pierre, of course, had been dead 5 years. She was a young, attractive female. Picture of her in that year, a very pretty young woman. Langevin, however, was married with 4 children in a very apparently unhappy marriage because he was doing science. His wife, science didn't pay very well. His wife wanted a more luxurious style and complained to him about not having enough money. So apparently it was a very unharmonious relationship. And some sort of relationship between Langevin and Marie Curie occurred. Her son, his son, Paul, Paul's son, Andre, wrote a biography of his father later on, in which he wrote, "Is it not rather natural that this friendship, intensified by mutual admiration many years after Pierre Curie's death, gradually transformed it into passion and a romantic relationship?" We don't know what the relationship really was, but he had certainly, it's well known that he had a very unhappy marriage. The press, however, took out after Marie. They ran really nasty, ruthless, anti-feminist, anti-foreigner campaign against her. Marie was not even in Paris when this started. She was in Brussels attending what was called the very first Solvay conference. Here's a picture of the Solvay conference. These were funded by a very wealthy Belgian industrialist. And some of the pictures here of people, there's Ernest Rutherford, there's Einstein, there's Marie Curie right at the center of things. Every one of these people here is super famous. Because of the time, I want to skip some things. When she got back from Belgium, she had to face this really venomous press. But at the same time, she received a telegram from Stockholm saying that she had been awarded the Nobel Prize in Chemistry for isolating radium. And the isolation of this tiny amount of chemical, again, came from her ability that she gained back as a student in terms of qualitative and quantitative analysis of how to pick out small pieces of things. So she is the only person ever in history to win Nobel Prizes in 2 different sciences. There have been some people who have won 2 Nobel Prizes. John Bardeen won two Nobel Prizes in physics, but no one has ever won one in physics and chemistry except for Marie Curie. But when she returned from Stockholm, having received that, things were so desperate for her that mobs assembled to attack her and chased her around, and she had to hide from people. She considered suicide and was deeply depressed, and eventually had to leave Paris and went to London to stay with a good friend of hers, Herta Ayrton, who's a very famous scientist herself. The relationship with Langevin was long over. He had separated from his wife and was living apart. The scandal and the cessation eventually died, but it took many months before she could return to work. Years later, her granddaughter, Hélène Joliot, married Paul Langevin's grandson, Michel. And so that relationship still had some serious romance. The start of the First World War in 1914 stopped her scientific research, but since she was the French expert on X-rays, she equipped lots of ambulances with X-ray machines and took those to the front line along with the 17-year-old Irene, are now sufficiently old to help her mother, and they were able to help treat wounded soldiers with X-rays for the first time. But the exposure to the horrors of war turned her into a deeply pacifistic woman who had refused ever to have anything to do with any sort of military things. And one of the things that made her a good close friend of Einstein, who, even though he was on the German side, was also a pacifist and refused to have anything to do with the German side of warfare. The Radium Institute, which she founded, lacked radium, which was used commercially for things, but an American friend started a subscription that enabled her to get the money to buy a whole gram of radium, and she went to America to receive that, was given it by the president, who at that time was Warren Harding. And she toured the US yet again in 1929 when she got another gram of radium, which she gave this time to the Polish Warsaw Institute. Her daughter, Irene, like her mother, was deeply dedicated to research and not very interested in things outside her work. She had married a French physicist named Frédéric Joliot in 1926, and they both adopted the name Joliot-Curie together. And they came within that close to discovering the neutron in 1932, and they made an error and missed that, and so they didn't, that discovery won the Nobel Prize in physics, and they missed that. But they did create the first artificially radioactive element, and that won them the Nobel Prize in chemistry in 1935. And so, as I say again, Marie and Irene are the only mother-daughter pair. Eve, the non-scientist who wrote the biography of her mother, was a great support and a non-scientist, but part of the reason she wrote a biography in 1937 was anger at what happened to her mother way back in 1911 when she was just a child, and she wanted to prevent anybody from writing a more sordid biography, which has never happened. It was in, and I'm almost finished. So, it was in the 1920s that the health hazards of radium began to become evident, because workers in the Radium Institute in France were becoming ill. Marie had sores on her fingertips. She had cataracts in her eyes. In 1932, she fell and fractured her right wrist. This did not heal well, and it led to a long decline in her health. She, of course, had worked for years with radioactive materials. She had no idea that it was dangerous and had no protective measures. In May of 34, she was diagnosed with tuberculosis, and Eve had her admitted to a health sanatorium in the French Alps. TB was a misdiagnosis, when she was there, she developed a high fever, and a blood count revealed that radiation caused then aplastic anemia, which led to leukemia very rapidly. And there in July 1934, the disease killed her. In July, she was buried next to Pierre, and in accordance with her wishes, the funeral was very modest. And if I read you one last quote from Eve's biography, on Friday, July the 6th, 1934 at noon, without speeches or processions, without a politician or official present, Madame Curie modestly took her place in the realm of the dead. She was buried in the cemetery at Seoul in the presence of her relatives, her friends, and the co-workers who loved her. Her coffin was placed above that of Pierre Curie. Bronia and Joseph Skłodowski, her sister and brother, threw into the open grave a handful of earth brought from Poland. The gravestone was enriched by a new line, Marie Curie Skłodowska, 1867-1934. Okay, and I think I've gone over an hour, so I think I will stop at that point. For any of you who might be around this afternoon, at 3 o'clock, I'm giving a talk on the Martians. This is a group of scientists in the early part of the 20th century who were all from Hungary, so unbelievably smart that people thought they couldn't possibly be from Earth. Therefore, they called them the Hungarians. The Martians, I'm sorry, they called them the Martians because surely they came from someplace else. And so today and tomorrow I want to talk about them. Today I will talk about the one I'm most impressed with, which was Leo Szilard. Anyway, if any of you are around for that, that'd be fine. Thank you very much for your patience today. Again, anybody who wants to